Okay, so let us start by taking a few functions in this video. So let us take let's say y equals or maybe let us write this in the variate functions. Okay, so let us take a function f of x. So this is the notation, right? So this is like this is the functional this is the variate functions. So let's say this first function is f equals x square. Okay, the second function will change the name. Okay, so I'll just quickly tell you how we write functions. So this letter here, f, g, or maybe any other letter, tells you the name. Okay, so these two have different names, f and g, two functions. Okay, here whatever we write in the brackets is the input. So functions are like machines, right? Whatever we put in here, so we put in x there, the input, and whatever you get out is x square. Okay, so this is like the y value, what you get out. So for more details you can watch the Khan Academy video, but that is the basic way we write functions. Okay, the input, this whole thing is output, and that's the name of the function. So the second function we'll take here is gx equals, let's say, x cube, and let's take another function a of x, okay, equals x raised to power let's say 5. Okay, yeah, so now we can all differentiate these three functions here, right? So I hope you remember the power rule, and using that we can differentiate this. So what we get is fx, when we write a prime sign there, this means that this also, okay, so this also means taking the derivative of it, right? So either you can write, so there are many notations to write derivatives. So the first one is, if you have a function, so forget that for a moment. Okay, if you have y equals x square, you can write the derivative as dy by dx equals, so you get 2x, right? So this is how you write the derivative. Or you can also write it as, if you are using the function notation fx equals x square, you can write fx. So this prime symbol here also means the derivative. Okay, so you just put this symbol there, equals 2x. Or you can use the same notation here, use y prime. So this also means this is a derivative of y equals 2x. So these are the three ways, first, second, and the third way in which you write derivatives. Okay, so you can use any of them, they are just equivalent. So we can differentiate this using the power rule, and we just saw that we get fx prime, the derivative, equals simply 2x. So you get the power at the coefficient place and reduce the power by 1. You get here the derivative comes out to be gx prime equals, so you get it at the coefficient place, the power, reduce the power by 1, so you get 2. And then you have a x prime equals 5x raised to power 4. I hope that is simple, right? So what I just did was the process of differentiation, right? I hope you know. So when I differentiate them, so there's a t there. Okay, when I differentiate them, I get these. Okay, so these are the primary functions. Okay, so this is a primitive function, as you may call, or the original function that you have. When you differentiate them, you get these functions, okay, which is a derivative. So these are called the derivatives of these functions. So if they were somehow, they have a relation between them, right? They're related. So if they were humans, for example, let us take the example of a father and a son relation. So I call my father as my father, so you are my father, right? But my father does not call me his father, right? He'll call me his son. So if I call my father, but my father will call me his son. So in the same way, if they were human beings, this function would call this as his derivative. So he can say him, you are my derivative, right? But what will he call this function as? So he can call this function as his antiderivative. So just like father and son are opposites, right? The same way, derivative and antiderivative are opposite relations. So this is its derivative, and this is its antiderivative. So you go here, differentiate, you get derivative. When you go from here to here back, you get antiderivative. Okay, so that is what an antiderivative is. And yeah, that's it for this video. In the next video we'll study where do we use the concept of antiderivatives. Okay, so yeah, that's it. Bye.